Good morning. Today we're going to talk about characteristics of functions. So we talked about these in class, about how all of these are functions. We're basically going to focus on things that involve straight lines or just one kind of curve. So we're not really going to do a lot of these kinds today. So we're going to start by graphing a function. All right, so we're going to solve this equation for y, and then we're going to put it in our calculator. So take a minute to go ahead and solve this equation for y and practice that again real quick. All right, so remember that the first thing you're going to do is get rid of the x. You have to move the x to the other side. So we're going to add 2x to both sides. Okay, if you do it that way, make sure that you don't combine the wrong like terms, because we don't want the wrong things. Oops. We don't want the wrong values to come up. All right, so now let's go ahead. These cancel out, and we get y equals 2x plus 8. Now you can put that in your calculator and you can plot points. Okay, so once you put that in your calculator and you plot your points, all right, you go to, where do you go to get your table? You're going to go to second graph to get your table. Okay, and then you're just going to get some points. So I know that I'm going to do a few points. I'm going to do -1. That should give me a 6, I do believe. And then I got a 0. That should give me an 8. If I go to 1, that will give me a 10. I'm just doing them in my head, so hopefully I'm right. Okay, and then you just plot the points. -1, 6. 1, 2, 3, 4, 5, 6. I think that's 6. All right. 0, 8. All right. I'm going to guess that these points are part of it because it's going to run out of my screen. All right, so we want to go ahead and graph that. There you go. That's how you solve for y and graph it. All right, the other way to do this is to plot your intercepts. And that's pretty easy because especially if you're looking for intercepts, you're going to want to just set this equal to 0. All right, when you set it equal to 0, when you set x equal to 0, you're going to find your y-intercept. Well, if -2 times 0, if you put 0 in for x, that basically covers it up, makes it go away. So your y-intercept is 8. It's pretty easy, so you just plot that point. So I'm going to plot my y-intercept of 8. That's on the y-axis. Then if you set your y equal to 0, all right, -2x plus 0, well, you don't really have to worry about that 0. So you do -2x is equal to 8. So we're basically taking this equation and turning it into something that we can solve. -2, so x equals -4. So our x-intercept is -4. Makes it super fast and super easy, especially if you're just looking for intercepts. And then you can connect the dots if you need to look at the graph. If all you need are the intercepts, here they are, right here, right? There's one and there's another one. So x is equal to -4, y is equal to 8. You could also write it as -4, 0, and then this is 0, 8. All right, so I'm going to skip that one. All right. So remember that they can be called zeros or roots also. So your x-intercepts can also be called zeros or roots. So when you're looking for that, you're looking for where it crosses the x-axis. So here you got one of them is -1. The other one is going to be 3. Okay, so you can write it like that if they're asking for the x-intercepts. Sometimes you might have to write it with the 0 at the y, but it means the same thing. Okay, if we want to label the zeros and the y-intercepts of this function, f of x equals x squared plus 5x minus 6, put that in your calculator. And so you go to y equals on your calculator. You're going to put x. You can raise it to the second power plus 5x minus 6. All right, then you go to your table Remember that second graph to get to your table. Big deal here, okay? You got to know what that is. And then you fill in some points. Okay, so I'm going to look in every spot on the table where there is the number 0. So if I scroll far enough, I get down to -6. There's a 0 with the Y. If I scroll far enough now, I have to go another way. Of course, X has always got some kind of thing going on at 0. So I've got 0, -6. And then right below that, or right above that, depending on how your calculator is counting, I've got 1, 0. I'm going to plug in a couple of points in between that that are going to fit on my graph. So I've got 2, 8. That'll fit on my graph. All right, and I've got, let's see, -1, -10. I just want to make sure I can get a curve going on here, okay? So let's go and plot these points. Okay, so I plotted a few points, and I looked at my graph ahead of time, so I know it's going to be kind of a curvy looking thing. I don't see the bottom where it turns, but I can estimate it for now. All right, I can't draw a curve, so I have to do little dots, and then I connect my dots later. Okay, so it looks like that, and then you get that. Okay, so now we want to know, where does it cross the x-axis and where does it cross the y-axis? So it's crossing at -6, 0 is one of my x-intercepts, and 1, 0 is my other x-intercept. My line is not drawn very well, but my points are, okay? So don't look at my lines. All right, and then my y-intercept is 0, -6. So this is an x-intercept or a 0. This is an x-intercept or a 0, what we're looking for. And this is my y-intercept. All right, so remember now we're going to talk about functions. So functions are special relations, right? They don't have any repeating x's, whether it's in a table that looks like, not this, I'm sorry, a list, okay? You don't want to have any repeating x's. So this second one is not a function because it has repeating x's. This one is not. But if it's in a table, let me go look and make a table here for you. You have a table like this, all right? If you have something like this, and somewhere down the line you've got another of the same thing in the x column. Now it doesn't matter, you can have the same number all day long here, okay? But this is not a function because of these, all right? This, I'm going to show you an example of a function, okay? 0, 1, 2. You can have repeating y's. That's okay. You just can't have any repeating x's. So this is a function, this is not. You can also do a vertical line test that's going to tell you whether it's going to have repeating x's. So anywhere on the graph, if you can draw a vertical line and it only crosses one time at any point, then it is a function, okay? So let's say you have something like this. Let me make one. I'm not even going to draw the x and a y axis because I'm just going to draw it like this, okay? Got a function on your x and y axis like that. If you draw a vertical line like this, look at that, crosses twice. So no, it is not a function. Okay, so remember, domain is a set of all your x values, and range is the set of all your f of x values or your y values, okay? So let's look at this. If you're going to try to find the range when the domain is this, all right, you've got to go and put this in your calculator if you want. All right, you don't necessarily have to graph it, but you have to at least look at the table, okay? So let's solve it for y. This is the same one that we did earlier. So we subtract 2x, or you can just move it to the other side and change the sign. Okay, put it in your table. And then when you get your table in here, you're going to have a table going on. All right, you're going to look at -2, -1, 0, 1, and 2, because that's what they're telling you the domain is going to be. All right, so then you just go and fill it in. This should be a 7. This should be a 5. This is a 3. All right, so I'm just looking in my table. This is a 1, and this should be a -1. Okay, so now that's your range. So your range is, now you got to put it in number line order. So your smallest y is actually -1. So your range is -1, 1, 3, 5, and 7. Okay. Let's talk a little bit more about direct variations. So these are all direct variations. They don't have anything hanging off the end. They just have a number times x. All right, and so remember that the form that it goes in is y equals kx. Y equals kx, so that's the form that you have to get it in. Okay, so I'm not going to go through all that. Let's go and find one that we can solve to find if it is a direct variation. Hold on, I'm going through the whole lesson. Is this a direct variation? Well, let's check. Okay, you have to get it in the form of y equals. So let's subtract 2x from both sides. 2x minus 2x here is going to cancel out. You have to bring down your -y. The sign in front of it goes with it. All right, 0 minus 2x, we don't care about the 0, is minus 2x. Negative. So it's looking like a direct variation. Let's divide both sides by -1 or multiply by -1, and we get y equals positive 2x. So yes, it is a direct variation, and our k is equal to 2. Okay, is this a direct variation? So let's start out again by subtracting our x. You got to get your x on the right. 3y is equal to -x plus 6. And then you divide by 3. Now look, I can tell already it's not a direct variation because of this little guy hanging off the end. But you get y equals, this is going to turn into a -1/3 x plus 2. It is not a direct variation because of that 2 hanging off the end. Okay, so now we're looking at an equation that we think might be a direct variation. All direct variations go through the line or the point 0, 0. But they can go through 0, 0 and not be a direct variation. So you still have to test it because this, let me show you real quick, this goes through 0, 0, but it's not a direct variation because it's not a straight line. So use your stat feature to figure this out, okay? So you're going to press your stat button. All right, oops. You're going to stat, and then you're going to edit. And you're going to put all of those in your L1 and your L2, okay? And then you're going to do stat, and then you're going to calc it. And now a direct variation is always a line, so you're going to go to a linear regression, which I think is 4. And you're going to hit enter until you get an A and a B. Your A should always pop up to be a number, and in this case it should be a 5. And your B will always be 0 if it's a direct variation. If it's not a 0, it's not a direct variation. All right, so let's go through and find some other ones. Okay, so when you're missing a value, you're told that it's a direct variation, all right, and you know 1 point, okay? So you can go through and plug it in and figure this out, all right? So you're going to plug in your y, and you're going to plug in your x, all right, which is 5. To find k, you're going to divide by 5, and you get k is equal to 14 over 5. That's great. And then you plug it back in, and you get y equals, now we already know the other half of this point, so it's 28. So instead of y equals kx, we're going to write 28 equals 14 over 5x. And then we solve it for x, okay? Once you calculate it, you get x is equal to 10. All right. The other way to do this is to set up a proportion. All right, so we're going to do y over x. So 14 over 5 is equal to 28 over x because we're looking for x. Cross multiply. Once you cross multiply, you're going to get this, okay, and then x is 10. All right, that's about it for direct variations and functions.